we have a function given and we have to simplify the function into this format. So let's start with the function. Fx equals to thrice x plus 1 divided by twice x squared plus 7x minus 4 minus 1 by x plus 4. It's a good idea to do the simplification separately. So for twice x squared plus 7x minus 4, if we do middle term break, it would be 2x squared plus 2 fours are 8. So this would be 8x minus 4. That would be plus 7x. So twice x plus 4 minus 1 x plus 4, and that makes it x plus 4 twice x minus 1. So what we can do over here, so fx equals to 3x plus 1 divided by x plus 4 twice x minus 1 minus 1 by x plus 4. Now we can take x plus 4 as the LCM, and the leftover is twice x minus 1, so twice x minus 1. So x plus 4 and twice x minus 1 matches, so what we have is 3x plus 1 minus x plus 4 matches, which is 1 into twice x minus 1. So what we have over here is fx equals to, so this is x plus 4 twice x minus 1, and this would be thrice x plus 3 minus twice x plus 1, and it is x plus 4 divided by x plus 4 twice x minus 1. Now this x plus 4 and this x plus 4 cancels off, and what we have left over is 1 by twice x minus 1. And that's what it was. Question number A, show that fx is this. Now for question number B, what we have to do is find the inverse. Remember, from now on, fx is this expression, 1 by twice x minus 1. So for inverse, the first thing we do is let y equals to that expression, which is 1 by twice x minus 1. So now for inverse, we have to convert x to y. So therefore, this would be twice x minus 1 equals to 1 by y. Therefore, twice x equals to 1 by y plus 1. Therefore, x equals to 1 by y plus 1 divided by 2, and that turns out to be 1 by twice y plus 1 by 2. So therefore, f inverse x is going to be 1 by twice. Since we are writing x over here, we cannot write y over here. We have to write x plus 1 by 2. For question number C, some people might find it difficult to do a domain range sum, but it is quite simple. Now, to look at it quite straightforward in a straightforward manner, f inverse x is 1 by twice x plus half. Now, domain means some sort of a restriction. Now, nothing can be divided by 0. So in that terms, the domain should be x is a real number, but x is not equal to 0. So that's a very straightforward way of thinking of it. And if you think about fx equals to 1 by twice x minus 1, in that case, downstairs will be 0 if x equals to half. So the domain of fx would be x is not equals to half. But to look at it more elaborately, because some people might find it difficult to do sums regarding domain and range, let's take a look what fx looks like. Now if you just Google it, you will see that by writing this out. So fx looks like this. So fx equals to 1 by 2x minus 1. So this is fx, and this is the asymptote, so it becomes x equals to half, downstairs equals to 0, that is the asymptote. You need to know the C1, the rules for sketching asymptotes. So this is the asymptote. Now this is the picture, this is one of the hyperbola, this is the other hyperbola. Now in the question, it is given that x is greater than half. That means we only use this portion. On the right hand side of the asymptote, this portion is not needed. So the other asymptote is y equals to 0. So the domain they have given, instead of x is not equals to half, this is supposed to be the regular domain. They have given us the domain x is greater than half. And that means we are going to use only this portion, because greater than half means on the right hand side, this portion. So in that case, the range is going to be fx is greater than 0. So that is the domain, this is the domain, and this is the range. Now for f inverse x, regardless of what it is, you can do it as the range of fx is the domain of f inverse x. So for f inverse x, x should be greater than 0. That should be the domain. That is the rule for domain range of fx and f inverse x. The domain of fx is the range of f inverse x, and the range of fx is the domain of f inverse x. That is one way of thinking of it. So it really helps if you know what the picture of fx looks like. So here we can straightforward, we can just write x is greater than 0. That is the domain of f inverse x. Now the final one is a composite function. We know fx. Remember, from now on fx is this one, and we know gx. We have to find the composite function f gx and solve it. So if we solve this like this, so question number D turns out to be, so gx is inside of fx, so equals to 1 by 7. So we can write, so fx is 1 by 2x. So instead of x, we write gx. So 1 by 2x minus 1 equals to 1 by 7. And instead of gx, what we can write is ln x plus 1 minus 1 equals to 1 by 7. 1 by 2 ln x plus 1 minus 1 equals to 1 by 7. If we do cross multiplication, 7 equals to twice ln x plus 1 minus 1. So this would be 7 plus 1, 8 equals to 2 ln x plus 1. So this would be 8 by 2 is 4 equals to ln x plus 1. So this turns out to be ln x plus 1 equals to 4. So as you know about solving logarithm or exponential function, it is going to be ln x equals to a. Therefore x equals to e to the power a. That is the rule. So that means therefore x plus 1 equals to e to the power 4. Therefore x equals to e to the power 4 minus 1.